When solving 3 by 3 systems, we have possible solutions. We have one solution, infinitely many solutions, or no solution. And if we have one solution, it's where all three planes meet at a point, so they intersect at a point. This is actually called an ordered triple instead of an ordered pair, because I don't have two, I have three. The next solution type we have is infinitely many solutions, and that's where they intersect to form a line. Okay, and y'all can see that where the planes intersect here to form this line. And it's also where all three planes overlap. When we solve equations with infinite solutions, we usually end up with some number equals some number. Like we saw in our homework assignment where I guess 18 was equal to 18. So therefore we knew it was infinite. Then we have no solution, and that's where you could see that they intersect to form three different lines. So you can see this line, this one, and this one right there. The second type that we have would be where we have two planes that are parallel, but they're intersecting another plane. The third type that we have is where all three planes are parallel. Okay, this one would be where we would have a number and it's not going to be equal to another number. Like where we had in our homework where we would have like 4 equals 0. Obviously those are not equal to each other. And we're going to solve 3 by 3 systems using elimination. So the first step that we're going to do is pick a variable to eliminate. We're going to use elimination to take away one of the variables. And we're going to solve the remaining two equations using elimination or substitution. And then finally we're going to plug both variables from step 3 back into one of the original equations to solve for the third variable. Okay, I'm going to look at the equation 3x minus 2y plus 4z equals 35. Negative 4x plus y minus 5z equals negative 36. 5x minus 3y plus 3z equals 31. So I'm going to pick a variable to eliminate. In this case, I'm going to pick the y's. Now, when we pick a variable to eliminate, we're going to use all three equations to eliminate. I first start with two equations. And what I want to do is, with those two equations, is I want to eliminate the y's out of two of the equations. And then I'm going to choose two other equations to also eliminate y. So in this problem, I'm going to choose the first two equations. Negative 4x plus y minus 5z equals negative 36. And I'm going to pick first equation, which is 3x minus 2y plus 4z equals 35. Now, I want to eliminate the y's, so what would I multiply to the top equation to make the y's go away? Positive 2. This is a positive y already, and this is a negative 2y. So if I multiply everything through by 2, then the y's will go away. So we draw our line, and we combine these. So the y's will go away, and that's what we wanted. And I'm left with negative 5x minus 6z is equal to negative 37. I have one equation that I've solved for and eliminated the y's already. I got that equation from the first one and from the second one, just so y'all know where I'm getting them. And now I'll do this again. I chose 1 and 2, and I chose 2 specifically because of this y, because I could multiply any number to y and get that number out of it. So it's easy to eliminate something with one y. So I'm going to choose 2 again, and then the other equation. So we have negative 4x plus y minus 5z equals negative 36. And the second equation was 5x minus 3y plus 3z equals 31. Again, I'm eliminating what letter? Because our goal is to get rid of the y's. So what do I need to multiply to this equation to get rid of a negative 3y? Positive 3. So 3 times negative 4 is negative 12x. 3 times 1y is 3y. 3 times negative 5 is negative 15z. And 3 times negative 36, negative 108. And draw our line, and let's combine these. And notice the 3y's do go away. I have a negative 3y here. This y is positive. I want it to be opposite pairs. So if I multiply by a positive 3, I'm going to get a positive 3y here. Positive 3, negative 3 cancel out. So negative 12 plus 5 is negative 7x. And then negative 15 plus 3 is negative 12z. And negative 108 plus 31. Negative 77. So now I have two equations that are now two variable equations instead of three variable equations. So this is what we had at this point from yesterday. So now I'm going to use what I learned yesterday to solve these two equations. And so let's just line up 5x minus 6z equals negative 37 and negative 7x minus 12z equals negative 77. Okay, we're going to decide what we're going to eliminate. So I'm going to eliminate the z's. So what do I need to multiply by the top one? Negative 2. Okay, let's draw our line and combine these two numbers. Or we add 10 and negative 7. We combine them. We get a positive 3x. The z's go away. And negative 77 plus 74 is negative 3. And then we divide both sides by what? So x is equal to negative 1. So I have part of my solution here. I know in my triple, my answer, my solution, I already know negative 1. Negative 1 is x. I got to make sure I put it in the order triple where the x would go in the order triple. Okay, now look at the next one. Got x is equal to negative 1, so I plug negative 1 back into one of the original equations. Doesn't matter which one. I just chose the negative 5x. Because I'm not going to choose one of these up here yet because I don't know what y is. I would still end up with an extra variable. So I eliminated y so that I can find out what x and z are, and then I can plug them in and find z. So we make it shorter. I'm plugging it into one of the orange equations because that's how we got negative 1. So negative 5 times negative 1 minus 6 times, we don't know what z is, do we? And that's equal to negative 37. So this will be 5 minus 6z equals negative 37. Solving for z, so we subtract 5 from both sides. So negative 6z equals negative 42. So what is z equal to? 7. So I plugged negative 1 in for x right here. Now what am I going to do with the 7 and the negative 1? They're going into one of the originals because I already got two of the variables. Can I now substitute those numbers that I do know into one of the three variable equations? Yes, and so I'm just going to plug it into the top one because that looks the simplest. 3 times negative 1, because that's x, minus 2y, we don't know what y is, plus 4 times 7 is equal to 35. Negative 3 minus 2y plus 28 equals 35. When we combine like terms, there's a negative 3 here and a 28, so that will be 25 minus 2y equals 35. Subtract 25 from both sides. Negative 2y is equal to 10, so y is equal to what? Negative 5. And there are so many steps here, and they can be done in so many different variations that it's conceivable in this classroom that everybody does the problem in a different way, and as long as your math is correct, that we would all have the same answer. okay, because we can all shoot off in a different direction. I might have at this point decided to solve for x. You might have chose two different equations to start with than the two I started with. X is -1, y is -5, and z is 7. 5x plus 4y minus 5z equals -10. -4x minus 10y minus 8z equals -16. 6x plus 15y plus 12z equals 24. Pick a variable to eliminate. In this problem, I'm just going to pick x's. There were no 1's or anything in 1 x's or 1 y, so I'm just going to pick some x's to eliminate. And just like before, I'm going to pick the first two problems to eliminate. I'm just going to pick 1 and 2. I can choose 1 and 3. I could choose 2 and 3. There's just 3 different combinations I can choose there. I'm just choosing 1 and 2 because it doesn't look like one's any easier than the next. And I want to eliminate something. I already said that I was trying to eliminate the x's. And the reason why I did that is I noticed here that one's positive, one's negative. So it'll be real easy to get an opposite pair. So I'm going to multiply the top by 4 and the bottom by 5. Draw our line and combine these. And the x's do go away. That's what I want. 16 and -50 combine to give -34y. -60z, and this is equal to -120. So I have a line right here. My goal was to get rid of the x's, and did I succeed? Yes. So now I'm going to pick 2 more equations up here. I can pick 1 and 3, or I can pick 2 and 3. I just can't do 1 and 2 again. But I'm going to pick equations 2 and 3. So what I have is 2 and 3. Let me write those down. And again, I got to keep my main focus the main focus. I'm eliminating the x's. Yes, because I want to get a y and a z. If I eliminate something else, then I don't have y and z. So to eliminate this, these are opposite pairs again, so it's nice. Multiply the top by 6 and the bottom by 4. When I draw the line and I combine, all of these cancel and leave me 0 on the left-hand side, 0 on the right-hand side. So this one's infinite, and it's only infinite because the first time I did this equation, I got a line, but the second time I got 0, 0. So the 0 equals 0 tells us infinitely many solutions, but I got what first? What did I get first? I got a line. So if I have a line, I do need to check to see if to keep going. In this case, I got a line and 0 equals to 0. I got a true statement. Infinite solution. And in this problem, I'm just choosing to get rid of the b's. Again, I need for these two, I'm going to use the first 2 equations to eliminate. So I'm going to write down the first 2 equations. So we end up with 6a minus 9b plus 12c is equal to positive 21. And if I rewrite the top equation, okay, so if I rewrite the equation, we get 0 equals 0. This would tell me it's infinitely many, but I haven't tried the other equation. Remember, I've still got an equation dangling out there in space, so I have to look at that one as well. So I do have to try the other 2 cases. I'm just going to try 2 and 3 again. I want the what to go away? The b's. So I still have to be in the same format. I still have to stay focused with what I want to go away. I want the b's to go away, so we're going to multiply everything by 5. Let's draw our line, and this time when we combine our 2 lines, I get 0 equals 5, and this is not a true statement. This one has no solution. I still have to include the third equation